Okay, so in the last videos, hopefully you saw how some of the pieces of the Muon detector come together. And I think we left in the last video with this on the screen, sort of seeing the output of the TAC in action here. We have some pulses with a certain time delay between them. And what the TAC will do, time to amplitude converter, we'll look at this time and convert it to some amplitude or voltage, which is proportional to the time between the pulses. And you can see as I turn the knob on the pulse generator to vary the time between the pulses, you can see the height of this pulse change in proportion to it, all nice and linear. So, the data that we're going to get in this experiment then is really just logging the height of this pulse here. So we like just to turn the simulator on, maybe for a day, a week, a month, whatever, and just let it sample pulse pairs that come in. Again, the setting on the TAC, any pulse pairs between 0 and 10 microseconds will generate a pulse like this. If it's outside of 10 microseconds, it'll just be rejected. So just start looking for these pulse pairs and log this height somehow to the computer. Now, how are we going to do that? Well, you already know how. The computer has these wonderful USB boxes here, and you know we have this mode for the software that drives them called pulse height analysis mode. So what that'll do is it'll sample the height of a pulse going in or a voltage coming in and make a histogram out of the voltages that it sees. So what I've done on the oscilloscope then, over here on channel 2, is this cable right here is coming from the TAC. That's what's giving me this pulse right here. But I've also just teed off onto it right here, so I'm sending this other wire here to go into the USB box. And so essentially I'm sending into the USB box this pulse right here for analysis by the computer. So what we'll do then is we'll go up here and see if I can get both on the same screen, in the same image like this. I think I can, something like this. Okay. So you'll have to watch this video very carefully because we're going to calibrate in a minute, or maybe I'll stop and go to the next video for that. But essentially what we have happening here now is you can see the two pulses on the oscilloscope here, and I have the oscilloscope set at 2 microseconds per division. I think you can clearly see the divisions, and you can clearly see the pulses coming in from the data, from the scintillation detector. There's our data throughput as it goes. But now on the computer screen, of course, we have it running in PHA mode, that pulse height analysis mode. This will be counts, and this will be channel here. So what we need to calibrate, of course, then is for a given height of this pulse here, and of course, as you know, the pulse heights can vary, what channel is the computer going to throw a given voltage in? Very small pulses will be over here, very large ones will be over there. So in other words, the pulse pairs that have a very small time between them will be over here, larger time between them will be over there. So in the next video, what we'll do then is we'll do a bit of calibration because you'll need this for your data. We need to see what pulse time between pulse pairs corresponds to what bin 0256 in the PHA mode, because we want this axis to ultimately be time, which would be the time between the pulse pairs on the oscilloscope. So get ready then for the next video, because what I'm going to do is I'm going to turn the computer on so it starts tracking, starts working in PHA mode. I'm going to vary the time knob on the pulse generator, and we're going to establish a table of time between pulses versus channel so we can get that x-axis calibrated. So that'll be in the next video.